In this video, we are going to look at some examples of multiplying and dividing rational expressions. Let's see if we can tackle number 1. It's kind of a doozy to start with. Remember, when you're doing multiplication and division of fractions, you actually don't ever do division the way that it's written. So this is a division, and we're going to need to fix that before we can even get started. We don't do division. Instead, we change it to a multiplication. So we're going to keep the first one. So we're going to keep negative 4x plus 12 over 2x plus 10. Change it to multiply, and then do the reciprocal or the flip of the second. Keep, change, flip. Once we have it written as a multiplication problem, one thing you could do in multiplication is multiply across the top and then multiply across the bottom. That is going to be a lot of stuff here. We've got a lot of things going on. Think about this as like a term, so you'd have parentheses, or a factor, so you'd have parentheses here. You'd have to be like foiling, and oh my goodness, it would be a mess. A better plan would be to see if we could get rid of some of these things before we multiply. Basically, reduce first and then multiply. But remember, in order to reduce, we have to be able to cancel common factors. And right now, we are not in factored forms. So we're going to look at this again, but instead, rewrite each of those as factors. So if we look at the first one on top, I've got negative 4x plus 12. I have a GCF of 4 that we could pull out. So if I pull the 4 out, I would be left with negative x plus 3. On the bottom, I have a GCF of 2, which would leave me with x plus 5. Now this is kind of odd. On the top of the second one, they already have it factored, but they've written it in that fancy way. So I'm just going to write it as the old school way because this makes it easier for me to see it. Remember, when you square something, it means that thing times itself. And then on the bottom, that's a difference of squares. So x minus 3 and x plus 3. Now I'm looking for common factors that we can reduce. And in order to reduce, one's got to be on top and one's got to be on bottom. And right away, I see this x plus 5. And that's gone. And I'm not seeing a lot of other things, but you know what? This factor right here is very similar to these, but its signs are really backwards. I think what I want to do is go back to the top here, and instead of pulling a 4, let's pull a negative 4. Now, if I pull a negative 4, it's going to change my factor here. So let's fix this. This would now be, let's see, if I pull a negative 4 out, it's going to change it to a positive x and a negative 3. Good thing we did that. It does match a factor over there. X minus 3 and x minus 3. And then we're pretty much done, but I see one more little thing we could do. Remember that 4 we pulled out, negative 4 we pulled out? He's called a greatest common factor. And this 2 is a greatest common factor. They're eligible for canceling, and this guy's on top and this guy's on bottom. We can reduce those. Just like if you had 4 over 2 as a regular answer, you would reduce that. So we're going to pull a 2 out of here and a 2 out of here. Now don't lose that negative. He's still part of this, okay? All right, let's see what we got. I think I'm done. Let's put it together and then we'll look at it again. Up top, I have a negative 2 and a factor of x plus 5. So that would be negative 2 and x plus 5. On the bottom, looks like everything canceled. Technically, I have a 1, but technically they're all 1s. And an x plus 3 factor. Since the x plus 3 is the only factor left on the bottom outside of 1s, we can just write it x plus 3. It doesn't need its parentheses anymore. And before we say we're done, we're going to look at this and see, are we really done or did we miss somebody? I think we're really done. There's nothing else we could reduce with. Now, when you look at number 2, you should be doing a little bit of a happy dance here because I don't see any add and subtract. And if there's no add and subtract, this problem just got a bunch easier than the last one. Remember, we're canceling common factors. Well, if it's all multiply, they're all just factors. We don't have to worry about factoring. We have it. We're just pulling out the common factors. So let's see what we could get rid of here. Well, I've got some y's going on here and some x's. Let's see. Let's start with the x's. I can get rid of this x with one of these x's. As far as the y's go, I've got 3 here up top and 2 on the bottom. So we could cancel out 2 of these, so it'd leave me with y squared. And I could get rid of 2 of these, so those are gone. As far as letters go, I think that's all I can do. I've got some y's here and I've got some y's here, but those are both up top, so we can't cancel those. Let's talk numbers. Let's see, how about 9 and 12? 9 and 12 have a common factor of 3, and 3 goes into here 4 times. And then I think that's it, but if you're smart, you're seeing one more. Remember, what we're doing here is reducing fractions. We're just reducing before we put them all together. And so you can reduce like we did here on the diagonal, but you can also reduce this way, as long as one's on top and one's on bottom. And now I bet you're seeing that 4 in your 8. So let's get rid of that. Let's see, 4 goes into 4 once, and 4 goes into 8 twice. I think that's it. We've got a mess going on here, so let's be very careful as we put this together. Up top, let's see, I've got 5. Those canceled. Y squared, 1, that's not going to matter, and a y. So it looks like I've got 5 y cubed. On the bottom, I think everything canceled letter-wise, and I just have 2 times 3, or 6. Now, I will say that 4 over 8 was a little sneaky. If you hadn't caught that, your answer over here would just have the same thing, only blown up by another factor of 4, and you could have just taken what you got in here and reduced it, and you'd get the same answer. So if you don't catch it, it's fine. You can just keep going and go again. Let's do one more. In example 3, good news, it's multiply, so we don't have to worry about keep, change, flip. Bad news is we've got a lot of add and subtract going on, so that means we're going to have to get all this stuff factored before we can do anything. So I look at this and I go, oh, crud, this one's going to be a little bit more fun to factor. So we're going to take him out to the side here and factor him because he's a little intense. He's got a lead coefficient of 2. So one way you could factor that is using AC method. So I'm just going to come over here to the side and take this guy and work with him for a minute. Remember AC method, I'm taking 2 times 3. That's going to give me 6. It's positive. And since my 5 there is positive, I want 2 positive things that multiply to 6 but give me a 5. Well, that's going to be 2 times 3. So I'm breaking my 5x up into 2x and 3x. And then we're going to use our grouping technique. First 2, I can pull a 2x out. That would leave me with x plus 1. Second group, I could pull a 3 out. That would leave me with x plus 1. So my GCFs are 2x plus 3. And my matching factors are x plus 1. Remember that x plus 1 didn't disappear. It's just we're multiplying 2x and 3 times it. So this is another way of writing it. Now let's come back over here now that we've got that factored. We're going to put it up top. And let's get the rest of this factored here. On the bottom, I see a GCF. So we're going to pull a 3 out. Don't forget about those GCFs, guys. On the top, now this one needs to be factored, but it's got a lead coefficient of 1, so we can go straight to it. You could also do AC method if you wanted to, but I know it's going to be x times x to give me x squared. I also know that my factors of 2 are just 2 and 1. So let's see. Let's talk signs first, though. If it's a negative 2, that tells me I'm going to have one that's positive and one that's negative. Again, it's got to be 2 and 1. To get a positive 1 in the middle means the bigger number, that 2, is going to have to be positive. And on the bottom, we have difference of squares. So x minus 1 and x plus 1. All right, that's the hard part. Now we get to do the fun part of canceling some things. In order to cancel, we're looking for common factors that we can reduce. So one's got to be on top, one's got to be on bottom. I'm seeing this x plus 2 that we could get rid of. I see an x plus 1 that we can get rid of. And there's one more. Do you see it? Remember, don't stick to just the diagonals. We're reducing here. So as long as one's on top and one's on bottom, we can cancel them. I think that's all we can do. Up top, I now have a factor of 2x plus 3, and that's it. So I don't need the parentheses. I can just write it 2x plus 3. And on the bottom, all I have left is a little old 3. Now, it is so tempting to want to reduce by canceling those 3's. But remember, this 3 is attached to another piece. This is an entire factor of 2x plus 3. So it would only cancel with another 2x plus 3. You cannot cancel with addition. It has to be multiply. Here, this is 2x plus 3 times something else, so we can cancel them. This is an add. We cannot cancel those.